Today I want to start on the introduction of the matrix, and it is a start of our course on linear algebra. Now let's have a look at this. This simply is a number, and it can mean anything. It can mean 3 apples or $3 million or whatever. It might be a bit more interesting if I add another number, and all of a sudden this gets a different meaning, because if I have an x-axis here and a y-axis there, and then the point 3, 2 obviously are the coordinates of this point. Or I can start all over again and say, okay, I start with the number 3, I add another number 2, and all of a sudden this is a vector. For instance, starting from the origin to this point. So numbers and what you can do and what they portray changes if you add other numbers. I start with a number. The number is 3. And now I'm going to add other numbers. And all of a sudden I have something different. I have an array of numbers, or as we call it, a matrix. Now, to what purpose could you use a matrix? We know the coordinates, we know the vectors, but what is the use of a matrix? Now, in order to give you an example where matrices are used, we have to go back to the beginning of the history of the personal computer. And I have a picture here of that. This was one of the first computers manufactured by IBM, and as you see, they had this monochrom monitor, only one color, green. And you may not believe it, but at some point this was an advancement of the previous line printers we used. Now, the next step, of course, was that we went to color, which was really very exciting, and we had monitors with 16 colors. Can you believe it? And every color had a number. Now, if we go back to our matrix in my Excel table here, you have here a matrix. And if you look at this table, this color table I just showed you, you can imagine that in fact this matrix is a picture. You see, where 6 means brown, 3 means blue, and so on and so forth. 0 means black. So in fact, pictures were made of numbers. And of course, going back to the matrix, you could manipulate this matrix. For instance, you could enhance each element of this matrix and add, for instance, the number 8. So 0 plus 8 becomes 8, 6 plus 8 becomes 14, and so forth and so on. Obviously, the picture that goes with this matrix changes then as well to this. Okay? Or another thing we could do was multiply each element of this matrix with a number. For instance, the number 3. Now, 0 times 3 stays 0. For instance, 3 times 3 becomes 9. 4 times 3 becomes 12. 6 times 3 of course becomes 18, but since I only have 16 colors, I multiply by 3 modulus 16. So therefore the result is 2. The picture that is the result of this change is this. So now we have already two things we can do with matrices. You can add a number to each element, you can multiply it with a scalar. Another thing you can do with a matrix is you can transpose it. What is that? To transpose a matrix, there you have it. You simply, let's have a look. This is the addition, this is the multiplication, and here we have the transpose, where you simply swap the elements, so according to the diagonal here. So this 0 goes there, and it swaps with this 0. The result is really not very shocking. But for instance, if you look at the 4s here, they swap and go over there. So in fact it is you mirror along this diagonal. Now what would that mean for the picture? As you see, the picture changes of course as well. And this is what we call the transpose matrix. As you can imagine, we quickly got bored by using only 16 colors. And one of the other systems that was introduced to give a more rich color picture was the so-called RGB system. R meaning red, G for green, and you guess already B for blue. And it worked like this. You see here, for instance, the three colors, red, green and blue, and together they make the color black at the moment. Now I can increase the amount of green, and obviously black changes to green, that is not a surprise. If I increase red as well, I get the color yellow. Now, as every picture is built from points or pixels, and every point has a certain color, for instance, suppose that this pixel here has the color yellow, then this means that the value of this pixel here consists really from the color comes from three values, being 255 for red, 255 for green and 0 for blue, which means that in fact you have three layers. The first layer is for instance the layer for red, which has a number of 255. Then behind that you have a layer for green, which has also the value of 255, and behind that you have the layer for blue. So in fact here you not only have a matrix in the horizontal and vertical sense for each pixel, but also in the depth. You can also go back in the layers and you have a three-dimensional matrix. And just out of curiosity, let's go back to one of the earliest color pictures, which was made in 1911, more than 100 years ago. And what was done was there were three pictures taken with different filters, one for red, one for green and one for blue. And then these pictures were projected on top of each other and together making the colored picture as you see it on the screen. So in fact, matrices can have more dimensions. They have 2 dimensions, 3 dimensions, and if you are going into the mathematics of it, it can have even more dimensions. And you see all of a sudden the whole universe is emerging.